Hello again, it's Dave Giles here for the second lesson of IGCSE Cambridge International Education Physics, Unit P1, Motion, Force and Energy. And today we're looking at density of solids. So we're going to look at the density formula and describe how to find the density of regular and irregular shaped objects. So first of all, density is mass per unit volume. So that's the definition of density there. And it's measured. So we use the formula there for mass divided by volume. Now, you can measure mass with this formula either in grams or kilograms, and volume either in centimeter cubed or meter cubed. So you would either use grams in centimeters cubed, in which case the unit would be grams per centimeter cubed, or use kilograms in meter cubed, in which case the units would be kilograms per meter cubed. And also, you need to know that to get the volume, if you're given sort of length, width, and height, you have to multiply them together as a regular shaped object to get the volume. Okay? So, a couple of very, very quick questions here. The density is the amount of mass per unit volume. This tells us how tightly matter is packed together. We measure density in kilograms per meter cubed or grams per centimeter cubed. Doesn't matter which way around you have these two. Calculate the density of a 20 kilogram box, which has a volume of 4 meter cubed. So density is mass over volume, 20 over 4, 5 kilograms per meter cubed. Make sure you've got the units on there. And then given the density of the box is 50 kilograms per meter cubed, calculate the mass of the box given the unit. So we need to work out the volume first. Length times width times height. Length 5, width 2, height of 6. Which gives me 60 meters cubed. Rearrange this formula here. And we get mass is density times volume. 50 times 60, which is 3,000 kilograms. Now, what you'll normally get, though, rather than getting the density of a sort of a shape like this in an exam, you'll quite often get the density of an irregular shaped object. So something like this, a knight from a chess set, for example. So you can't just do length times width times height to get the volume. So there needs to be a little bit more to it. So first thing you would do is weight using a top band balance or electronic balance, something like this. And you'd normally weigh it first, because the next step is to put it in water. Okay, and when you put it in water, it's going to add mass to it, so always weigh it first. Anyway, first thing you do is get a measuring, after you've weighed it, is get a measuring cylinder and record the initial volume of the water. Remember, always measure from the bottom of the meniscus we talked about in the last lesson. And it looks like this one here, I'm looking a bit closely, is initially on 48 centimeters cubed. Just to be clear, it might say milliliters on the measuring cylinder, but 1 milliliter is the same as 1 centimeter cubed. It then goes up to 59. So that has been an increase of from 59, it was originally 48, so that is 11 centimeter cubed increase. So to get the density of this, you do 39.21 grams divided by 11 centimeters cubed, the mass, the volume increase. So about 3.5 grams per centimeter cubed for this chest piece. So just to summarize, that is weigh it first, get a measuring cylinder full of water, and then put the irregular shaped object inside the water. Be careful when you put it in. You don't want to drop it in, otherwise it could splash out. So it's usually best if you tilt it on its side. You can also use something called a Eureka can, which is like this, with basically a can, sorry, with a nozzle, and then you put it in, the water displaces into the measuring cylinder, which is another way of doing this. Question, how would you find the density of an irregular shaped object that floats? So if we go back to this method here, this wouldn't really work very well, because if it floats, say half it's above the water, then it's not all, the whole object isn't going to displace the water. So if you have an object which floats, what you will need to do is weigh it down. So after you've recorded the mass, you'll put an object where you have a known volume on top. So let's say you used a lead block, you know the mass of the lead block. Sorry, more importantly, you know the volume of the lead block. You put it on top and sink it down. Now you could press down with your finger, but then your finger will displace and you don't know the volume of your finger, but you can put an object on top with a known volume. So let's have some past paper 2 questions. The mass of an object is 2.5 kilograms. The volume of the object is 480 centimeters cubed. What is the density of the object? So for this, it's given in grams per centimeter cubed. So you need to convert the kilograms to grams. So 2.5 kilograms, 2,500 grams. Divide that by 480 centimeters cubed. Gives me 5.2 5.2083. So to 2 significant figures, that is 5.2 grams per centimeter cubed. A student determines the density of an irregular shaped stone. The stone is slowly loaded into a measuring cylinder, partly filled with water. You can see here I talked about putting it in slowly earlier. He had put a bit of string on there, which will add a little bit of volume to it, but not much. Which other apparatus does the student need to calculate the density of irregular shaped stone? Well, we need to know its mass, and for that we would use a balance. So, a balance. A regular swimming pool is 50 meters long and 25 meters wide. It contains water at a depth of 2 meters. The density of water is 1,000 kilograms per meter cubed. What is the mass of the water in the pool? So for this one here, you've got 50 meters by 25 times 2 for the depth. So you've got a volume of 2,500 meters. So mass is density times volume. So 2,500 times 1,000 gives me 2.5 by 10 to the 6, which is this one here, 2.5 million kilograms. Okay, next question. A metal ball is attached to a cork and is lowered into the measuring cylinder, pulling the cork into the water as shown. The mass of the cork is 4.8 grams. What is the density of the cork? So this is what I was talking about earlier, where you've got an object which floats. Now the cork will likely float in water, so you can't just drop it in there. So what's the density of the cork? So initially we had 48. We then put the ball in, which took it up to 56. And then the cork went in, so went from 56 to 80 centimeters cubed. So that is a rise of 80 minus 56, which is 24 centimeters cubed. So density is mass over volume, so 4.8 divided by 24, which gives me 0.2 grams per centimeter cubed. So the answer for that one is B. Okay, thank you very much, everyone. Next lesson will be on density of liquids. I will be uploading that very, very shortly, and I'll post a link in the description. I'll see you for the next lesson. Thank you, and goodbye.